Welcome to the REACT Symposium today. Thank you for attending. I have one job, and that's to thank the sponsors of today's event. Solvay has been a kind sponsor, and they're here from Denis this morning. They've sponsored this event for the last 3 years, and hopefully for the next 7 years, as we go for our renewal in a couple of years. No, don't go anywhere. And my counterpart, since I'm the PI of the Penn, Patrice, Rannou, will also say a few words as the PI from Giant. And we also have Francine, who is a co-PI on the educational side, who works closely with Kristen. So what you'll hear today are a few interesting snippets of talks from faculty. Professor Mamie will talk about work on biofilms that she's been doing at Alabama State. You'll hear from REACT fellow Nadia, who's part of Act 3, about her research progress. And excitingly, you'll hear about two of our undergraduates, Mauricio and Sisan. We'll talk about natural disaster tent design, which beautifully segues into the keynote presentation that we'll have from ShelterBox today. So with that, I'll hand it to, I guess, Denis.
Oh, it's me first? Okay.
Yes.
So thank you, Ross, for the introduction. First, I want to say that I'm very happy personally to be participating in this. It's a program that I've discovered only a few months ago as we're aligning more and more, at least the interest of my lab and the CNRS people in the lab together with the team here, so I think it's really great. So far, there's not a single student that I've met that I haven't been impressed by. And really, I am. And I can tell you, I meet a lot of people that interview for positions and all, and so far, and I think it's really because of what you're going through, and then, of course, the talent for selecting the students, obviously. But the things that Solvay as a firm is going to be looking for more and more is people that are very entrepreneurial in their mindset when it comes to research, not just to research for the sake of doing research. I did my PhD on something that turned out to be completely useless, so I wish block of polymer structuration. No, but obviously it was because you were not my PhD advisor. So I can really appreciate that what you're trying to do through that program, because it's a really cool program, right? You're trying to help people out when they're being faced with catastrophes, and also I think it's really cool. A lot of you show a lot of passion, so I think that's something that you should hang on to, because you're going to have to work for probably 40 or maybe 50 years. So having passion for science is really something that is very important, that will drive you. So it's something that I recognize as very important, especially to see it in students that young. It's cool that it's also very, it's dear to the heart of Solvay people that, to do science that is sustainable as well. So you're working for something that is not just chemistry or physics, but something that also alludes to solving humanitarian questions. That entrepreneurship, I talked about it, I think is really important. The very cool project with the tent, that's super smart. And generally, like I said before as an introduction, I'm really genuinely impressed by every student that I talk to, as little or big as their contribution to their project is. You're always very knowledgeable, and you'll make great candidates for positions tomorrow in the industry. So I hope you'll see that there's a side to research that can be done in the industry as well. That is quite fascinating at the same time. Not exactly the same as what you could be doing on the public side, but we do pretty cool stuff as well. So come and join us one day. Thank you, guys.
So thank you, Ross, and thank you, Denis, for this kind word. So I will just finish very quickly before we have our next speaker making the real interesting stuff. So I'm just here to represent 20 PIs from the French side of REACT. So that's a huge job I'm handling with Francine Pavillon, who is in charge of the educational part. I'm just here for the science. And we have also the pleasure to have Manuel Maréchal, one of the researchers here with us for the first time. So it will be the third year of REACT. So we have been already welcoming more than 20 PhD students and undergrads, and the cohort 3, you know, we are eagerly looking forward to make you benefit of the environment. So please feel free to discuss and exchange with us. We are there till Thursday evening. We are available to anyone to discuss, and please also discuss with your former colleagues who went also to Grenoble. There's a land of opportunity. There's many things to do. Many researchers who are liking to make international collaboration, and if I can say, we are the past. We have found our path to a position, whatever it could be in the industry or in the academia, but we are also here to help you finding your path. So use us as much as possible, and we are eagerly looking forward to interacting with you all this workshop and also during the week with us. And you're part of REACT. You don't know, but you sign up ever for a lifetime, so whatever you will do, you will be always related to REACT, and that's good, I hope for you. Thanks.
Okay, so our first speaker is Professor Mamie from Alabama State University. She's been our collaborator for Act 2. And she's going to talk about the title here. Microbial competition between mucoid bacterial species.
Well, good afternoon, everyone. And I am Mamie from Alabama State University. And I would like to start off with a bit of a disclaimer. I'm a microbiologist, sorry. It's just what I do. And as I was reading and getting ready for my presentation, I was watching The Big Bang Theory. And I was just laughing at the way they're always, the more physical science guys are always laughing at the biological people. And then it flashed to me, you know that you're the biology person, right? So hopefully we won't have any Big Bang moments today. But I did change my topic from what I had mentioned earlier to Zaria. And I'm going to talk about how mucoidy affects pneumococcal infection in cystic fibrosis patients. So just a bit of an outline. I'm going to tell you the bacteria that I work with, and as well as talk about a collection of bacteria that we were able to put together, how this relates to cystic fibrosis, and how the bacteria behave in vitro and in vivo, and then open it up for any discussions. So in particular, this work focuses on Streptococcus pneumoniae, which is a Diplococcus, is gram-positive. I'm going to talk today mostly about the Capsular Polysaccharide. And what this is, it's just a sugar coating that's on top of the bacteria. But it's the main virulence determinant in the bacteria. It's what lets the bacteria live inside people. And this is going to influence what's called the serotype of the organism. The bacteria, most of us in here today, at least 90–95% of us are going to have Streptococcus in your nose. And as long as it stays in your nose, in adults and children, it's going to be fine. It's when the bacteria moves from being in a carriage state to a disease state when it goes into normally sterile sites, such as the lungs when it causes pneumonia, the middle ear where it'll cause otitis, or into bone and joints where it can cause bacteremia, septicemia, and arthritis. And while the bacteria is normally harmless, it is potentially fatal in adults and even worse on children. To the capsule. Right now there are more than 95 different types within this one bacterial species. You have 95 different capsular polysaccharide types. And the way to think about this is almost like they're siblings. Two parents have a set of children, but they're all individuals. And that's the best way to think about this bacteria. Not all the serotypes are going to behave equally. You know, everyone has that one kid that won't do right. Think about it like that. So they're not all equal. They don't all cause disease equally. They don't work the same way in animal models. 85% of the infection is normally due to about 23 to 30 serotypes. There are 95, but most of the infection is due to a small number of those. And classically, we're talking about type 3, which I'm going to keep using the word mucoid and mucoidy. And typically, That's going to be with serogroup 3, and it makes a large amount of this capsule, which even changes the way the bacteria look to the naked eye. But I'll go into that in a little bit more detail. And that sequence there, that's the repeating unit for the type 3 capsule. So what do we do? In 2002, Dr. Marilyn Crane at the University of Alabama in Birmingham began a collection of all of the pneumococci that came through Children's Hospital. Why did she do this? There was a vaccine that was instituted at that time called PCV7. If you have children or you follow the pediatric recommended cycle of vaccination in the U.S., you may have heard of PCV7 or PCV13 because it is part of that recommended scheme. Well, we knew that when you take a vaccine and put it into a population, you're probably going to wipe out whatever's included in the vaccine. But what most people don't think of is what's going to replace the bacteria that you wipe out. You're not going to make less bacteria in your nose. No, it'll change to something else, or other bacteria will take its place. Think about the seats in this room. If every seat in this room had to always be filled, but there was a line of people lying down the steps. So when one leaves, someone else just comes in and takes the seat. And that's what we wanted to watch. Also, the bacteria can change. New serotypes are going to come in that weren't included in the vaccine. And while only about 30 really cause disease, it doesn't mean that the other ones can't. It just means that they're not able to fight to get a way in to cause disease yet. So that's why the collection began. And as I came into the program, into the Dr. Crane's lab, I noticed that we had a lot of isolates from cystic fibrosis patients, which is unusual. If we're looking at all of the children that come through one of the major children's hospitals in the southern United States, I shouldn't see that many cystic fibrosis patients because they're a relatively small part of the population, but I did. So that made me curious as to why we were seeing that so often. And just a little bit on cystic fibrosis, it is genetically inherited. There's a mutation in the CFTR, which is located on chromosome 7. We mainly hear about cystic fibrosis and how it affects the lungs, and we think about lung infection, but a lot of the physical illness actually comes from the digestive system as well. What causes the lung infection in cystic fibrosis patients? Normally what happens in our normal pathway is that the salt and water balance is such that the cilia within our lungs are able to beat. And that ciliary beat is going to keep the bacteria from being able to adhere and cause infection. Well, in CF patients, what happens is that the mucus covers those cilia, so they're not able to beat. And it's also a rich environment, rich in nutrients for microorganisms, which is how they get infection. So what I found that when I looked at the particular bacteria that we were getting from CF patients, they didn't even look like the bacteria that I got from other children. They tended to be more highly mucoid. And that just means a glossy appearance on TSA blood agar, and they're usually larger, and they're much harder to manipulate. I don't know. We're not going to try that. But the ones, if you look at this slide here, that's considered highly mucoid, whereas this is considered a normal looking bacteria. See, they're much larger, like this is one colony here, and down here, this would be one colony. So they're going to be much larger, and they're different to look at, and they're actually much harder to manipulate. So how do these isolates differ, other than just in appearance? So we did capsular serotyping, and I'm not going to go through how this is done, but if anyone's interested, I'll be happy to explain it later. And what we found was that when we compared CF patients to non-CF patients of the same age, all of our strains are from children, we found that certain serotypes predominated. In this serogroup 3, which is the one I mentioned earlier, that tended to produce more capsule anyway, was statistically higher in our CF patients than in our non-CF patients. So the goal then became to see what does it have to do with cystic fibrosis. There are also some other isolates that predominated, but today I'm just going to focus on the serogroup 3. And I will say right here, this is one of the things with students where When you start to look for one thing, 15 other things are going to come up. We didn't start the project to look at cystic fibrosis. We didn't start the project to look at mucoid bacteria, but that's where we're going to go. So what does this have to do with the price of sweet tea in Alabama? And yes, I use my accent for that. Really, does the way these bacteria look have anything to do with cystic fibrosis? And to do this, we were able to use a mouse model that actually expresses the human CFTR gene in its lung. But this is a later generation cystic fibrosis mouse, so it doesn't have the intestinal issues that the earlier generations had. Typically, cystic fibrosis mouse models, the animals were very, what we would call puny. They didn't survive well. They might have lived a few weeks, but they died from intestinal problems. But this is called a gut-corrected CF model. So when we looked at these, we actually found something very interesting. And this is a strain table here. CHB means it came from our study. W2 is kind of the generic S. pneumoniae that most people use if you're just studying the bacterium. So it's not a recent isolate, it is a human isolate, but it was isolated many, many years ago. CHB 1058 was also isolated from us, but it was not mucoid. But if we look at the highly mucoid strain, and we look at lung homogenates or how long the animal survived, we see that there's a significant difference comparing this strain to all of the other strains. And if we look at the amount of capsule produced, we see that the typical lab strain, which we set at 100%, this CF 756 produced a far more capsule than that one did, and it also caused more disease and had a higher preponderance of death. If we look at the bronchial alveolar lavage, which is the bacteria sticking in the floating in the lungs as well as sticking in the lung, we still see that there's a significant difference. So yes, this does have a potential impact in cystic fibrosis. That's why these strains were coming out far more often than strains that appeared like this or this. And while I won't go anymore to my biofilms, there's also a difference in a way. The large mucoid strains versus the small mucoid strains were able to make biofilms. Looking close to the lower level, we see a beautiful mixture here of live and dead cells. And it's the same thing here. But when you go to a less mucoid strain, we see that it's actually not the same. There are far more holes in this biofilm, and actually the biofilm is very unstable. So just to summarize, we saw serotype distribution differences. The CF lung actually may have something to do with why these mucoid organisms predominate. Something I did not get to talk about, which was originally going to be my topic, was S. pneumoniae competing out Pseudomonas. So when we're talking about novel antimicrobials, there's a novel system going on here that hasn't been described, where it's when bacteria kills off the other one. And that's where a lot of our original antibiotics came from. Using bacteria and flow cells, we were able to study the different types of bacteria that we saw. The highly mucoid serotype 3 caused more serious disease, and we were able to use our CFTR model to actually support this. And I want to acknowledge my lab members as well as the groups at UAB and Wake Forest University and other people who helped with this study. And I'll take any questions.
Time for questions. Started a little bit early,
So you mentioned earlier about the importance of mucus inhibiting the beating of the cilia, right? Mm-hmm. Maybe this is more of the biophysics approach, but how well known is it, sort of the molecular details of that mucus in terms of its viscosity and its components? Because can we prevent it from forming is one approach, or can we have some inhibitors to prevent it from reaching a critical viscosity so the beating isn't impaired?
Yes, it has been studied and characterized. There are ways to prevent it, but it's when the CF patients have to put on their vest every day. I don't describe it well, but it's a shaking vest, and it makes this mucus not be able to stick. It'll make them cough it up, shake, 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 or they do hitting therapies.
Yeah.
Those therapies keep it from forming physical therapies.
Right.
But there are also things along the line of albuterols that help it to not form as well. But are any of those 100%? No.
So it's known that thinning the mucus,
Thinning the mucus,
lowering the viscosity to some extent.
Yes, it does have an effect on a positive effect on their overall health. Yes. How well it's been studied, I know that it's characterized, but I'm not sure what new therapies are coming in that area.
Yeah, so I remember you showed the slide with like the relative percentages of like the capsule material.
Mm-hmm.
Is it that material that contributes to the formation of the biofilm, or are they not really related?
Yes, it does contribute, but the short answer is yes. But there are other things, as many biofilms have a lot of components such as DNA and other polysaccharides that come as cells die and release into the environment. So yes, the capsular polysaccharide does play a role, but even if it's absent, the bacteria will still form a biofilm. It will just be different.
In your images of biofilm, can you go to that slide?
Sure.
It looked like the early image on the left looked very homogeneous in its composition rather than green, like randomly, and then the bottom one seemed to show that green ones are a little clustered.
Which one here?
Yeah. Is that real, or that's just...
No, it's real. So all of this is the same image.
Uh-huh.
If you look at this image here, it's at the base.
Uh-huh.
And this one is closer to the surface of the film. So when you get to the surface, you have this, where it's closer to the bottom, you have a mixture of live and dead.
So that is a known phenomena that they cluster like this? It's almost like phase separation.
For pneumococci. Yes.
And does the mucoid play a role? Does polysaccharide, or is it biological? So is it physical or biological? No Big Bang moment here.
What causes the dead ones to cluster?
I think it could be that the dead ones, you know, you're going to have more limited nutrients at the bottom. Even if you have the challenge, you're not going to have the nutrients and the oxygen requirements and all closer to the base, because this is 48 hours old. So these would have been deposited much earlier. These are probably newer cells, because we were reaching probably close to the critical mass of how heavy this is going to get. And I think that probably has a, and you know.
So what was the thickness of that?
I don't remember. And I don't have my measurements on this one.
Yeah, looking for the scale.
Yeah, I can't see the scale.
Okay. Yeah.
But that's going to influence it. And that's typical of biofilm. What's on the top is going to be alive. If there's nothing to impede it, they're going to be alive, and usually fairly healthy cells, but they are part of the biofilm. So when your antimicrobials come in, this is all that's going to get killed, because they're growing. So when you go down lower, down to here, and you're trying to do things to kill the biofilm, most of these are dead, but they're still a part of the physical structure. So when you're talking about antimicrobials, you're talking about needing to remove this, and if the bacteria are metabolically inert, that's going to be harder to do.
Other questions?
So what's known strategies then for allowing the antibiotic to penetrate the biofilm? Because that's something we're very interested in, to have the entire biofilm attacked by the antibiotics. But if it's a skin layer and then below the surface.
I don't know that there are any good therapies for getting down to the lower levels. Most of it's going to sit on the surface. And remember, S. pneumoniae is gram-positive. So gram-positives are actually more susceptible than, say, an E. coli. Because what will happen is gram-positive, you can get the surface, and you may get some in the deeper, but with gram-negatives, there's actually usually pumps to push it back out. The antimicrobials will go in and they'll push it back out. So anything past this first couple of layers, there are no therapies for that. So learning how the biofilm, how the channels work, if the bacteria can make it into a channel and follow through a channel, possibly, but that's not easy to do.
So would you say then the therapeutic approach then would be more to focus on limiting the adhesion or the formation of that base layer to begin with?
Yes. If you can tap a property like
release the whole thing.
The thin films that don't allow it to adhere in the beginning, if you can break up the adherence, you can prevent the biofilm from forming. Yes.
All right, we're done. Let's thank Mamie. Nadia Krook, Russ Composto, and Chris Mauricio. All right. Good afternoon, everyone. My name is Nadia Krook, and I'm a fourth-year PhD student. And as Ara said, I'm co-advised between Dr. Russ Composto and Dr. Chris Murray. And my work is in Act 3, where I am designing polymer coatings that control the alignment of anisotropic or non-spherical nanoparticles. And this is work that I brought with me this past summer to France as a 2017 cohort that traveled to Grenoble, working with Patrice and Manuel. So working in Act 3, Act 3 seeks to arrange novel nanoparticles to maximize the use of the solar spectra to create self-assembled nanomaterials for energy generation. And so our team's goal is to create optical waveguide coatings by synthesizing nanoparticles with primary properties for primarily optical properties. So our research in Act 3 aims to tune the separation and the alignment of such particles into the most efficient structures. So optical anisotropic or non-spherical nanoparticles, such as cadmium selenide in this case, can be assembled into different orientations, and in this way on a liquid-air interface to elucidate the effect of nanoparticle orientation on properties. However, when we want to start thinking about applying this to a surface for a tent as is the aim for REACT, we want to start thinking about putting these into some sort of coating technology, which is where my work comes in. And at the interface of Russ and Chris's group, I work on polymer nanocomposites that integrate nanoscale particles into polymeric matrices. And the benefit of these materials is that the resulting properties will possess properties of each component. So we can have the properties from the particles incorporated into a flexible, thin film, such as a coating. So some examples of some properties that we can incorporate into a polymer film are mechanical properties. So we can improve the mechanical properties of polymers, where in this case, clay platelets have been introduced into polymeric matrices, and by increasing the loading of the clay or the clay content, we can enhance the mechanical properties compared to the neat polymer system. We can also impart optical properties onto polymers. So in this case, we're incorporating gold nanoparticles into polymeric matrices, and then by increasing the loading and also just the incorporation of these particles, we can impart optical properties into the films. So the properties of polymer nanocomposites depend not only on the incorporation of these particles into polymers, but also on how they are arranged within the film, so how they're organized and also how they're aligned. So my work is really focused on the alignment of particles and what effect that might have on the properties of the resulting material. So we believe that through this, a new class of polymer nanocomposites could be revealed that would have a unique set of properties. So the analogy I like to use is with drinking straws. So imagine embedding drinking straws parallel into the substrate. So in this case, nothing could pass through the film. However, if we could reorient those drinking straws so that they're vertical to the film, now water could pass through. So the analogy here is, can we tune the properties of the film by changing the orientation of the particles? So could we change the properties whether they're parallel or vertically oriented in the film? So that's the goal of my work, is to create polymer nanocomposites with either horizontally or vertically oriented anisotropic or non-spherical nanoparticles. So there's different ways in which we could think about doing this. We could apply external fields, or in the case of Hitachi Chemical Company, they developed heat dissipating sheets by vertically orienting graphite particles. And the way they did that was they took this structure B, where they incorporated graphite sheets into a thermoset resin, and it started off with the particles being parallel to the substrate, and then they sliced up this structure and reassembled it to obtain structure D, which we see here in the image. And what they exhibited was an enhancement of thermal conductivity tenfold, going from structure B to structure D. But as I explained of how they created these structures, it was very much a top-down approach, so slicing and reassembling of the film to create these vertically oriented platelets into the composite. So my work aims to establish control alignment of anisotropic particles through self-assembly. So creating these self-assembled polymer nanocomposites with either horizontally or vertically oriented non-spherical nanoparticles. So the way I am looking to do this is using block copolymers to facilitate a hierarchical structure. So block copolymers are characterized by covalently binding two dissimilar polymers that are driven to microphase separate, because now we have these two polymers that are attached together that don't want to be close to each other, but they can only go so far. So this is a typical phase diagram for a block copolymer, where here we're looking at the chi-n, which is the relative attraction between the two blocks. So as we increase chi-n, mixing is discouraged, so these two linear polymers do not like each other. And then on the x-axis, we are changing the relative fraction of those two dissimilar polymers. And since they don't like each other, we can create these hierarchical structures from spheres to cylinders, lamellae, and then the reverse, as well as gyroids. So if the geometry of the template of these block copolymers and the chemistry matches the particles we want to incorporate into them, they can serve as templates for nanoparticles. So my work, in terms of aligning non-spherical nanoparticles, I am working with a lamellar forming block copolymer, so polystyrene block PMMA, or I'll refer to as PSB PMMA, and a nanoplate system. So just to introduce my system further, I'm working with this model nanoparticle system, and block copolymer system, and I want to achieve different modes of orientation of the domains. So I've established a parallel alignment of the domains. So here we're looking at a TEM image of the cross-section of a block copolymer formed on a silicon substrate. And the PMMA domain wets the silicon substrate. It preferentially wets the substrate as opposed to the polystyrene. And we can create these lamellar features parallel to the surface. And then if I change the surface chemistry of the substrate, making them neutral to both the blocks, I can actually get vertical lamellae. So here we're looking at a top-down image of the same block copolymer in a thin film with the domains oriented perpendicular to the surface. So now I've created a template with both domains oriented parallel to the substrate and domains oriented perpendicular to the substrate to serve as a guide for alignment of nanoparticles. For the purpose of this talk, I'm going to focus on my work with the parallel system. So I have my block copolymer formed, and now I'm going to incorporate the platelets into one of the domains. So in working in Chris's group, the platelet system that I work with is a model nanoplate system that's gadolinium fluoride doped with ytterbium and erbium. And it's synthesized through rapid thermal decomposition. And the reason why this is model for our purposes is that it's rigid, monodisperse, and I can tune the size and shape if I wanted to, depending on the precursors I use. But I picked this particle in this library because of the platelet shape, and also the dimensions are quite compatible with my block copolymer. So the domain spacing of my block copolymer is about 18 nanometers, and I'm incorporating a particle with the longest dimension of about 35 nanometers, the shorter diagonal of about 22 nanometers, and a thickness of about 3 nanometers. So when we think about incorporating a particle into a domain, we don't want to disrupt the local chain conformation and have too much of an entropic penalty to incorporate these particles in the system. So 3 nanometer thickness is quite compatible with my domain spacing. So as synthesized, these have oleic acid on the surface. So in order to incorporate them into a polymer matrix, I've changed the surface chemistry of my particles through a ligand exchange to functionalize these particles with PEG, so polyethylene glycol. And this is an ideal system in that now I've designed a particle that actually has a favorable attraction to one of my blocks. So in an undercooled melt, PEG and PMMA have an enthalpically attractive interaction. So I can disperse these particles quite well in PMMA. So this is the dispersion of these platelets with PEG on their surfaces. into a 20K PMMA matrix with increasing loading. And we can see here that these are quite well dispersed. And as I mentioned, the nanoparticle system now has a chemical specificity to one of my domains, so the PMMA domain in my block copolymer. And you can look at these TEM images, and again, these are top-down images, and say, you know, they look pretty dispersed, but they also look like they're pretty parallel to the surface already. So in order to investigate this a little further, I'm working a lot with tomography, where we can look at the out-of-plane dispersion of these particles as well. So this is taking a tilt series on the TEM of these particles dispersed in homopolymer. And what we see is that there are randomly oriented within the film, that there is no directed alignment in these films. So in order to establish directed alignment of these particles, I've incorporated them into my block copolymer. And so here we're looking at cross-sections of these images with increasing loading of the platelets. So from 5 weight %, we see that the particles are segregating to this lighter stripe, the lighter domain, which is the PMMA. 10 weight %, we see that effect as well. However, when we start to get to 20 weight %, we see that there's areas of disorder where the particles start to be randomly oriented. And then we do see regions of lamellar formation. And then once we increase loading to 25 weight % and then 30 weight %, the particles are randomly oriented. Our hypothesis is that in order to minimize the chain frustration, the platelets will align with their smallest dimensions between the block copolymer. So we can, just as a schematic, kind of a 2D representation of block copolymer. As we incorporate these platelets, the local chain conformation around these particles start to be disrupted. And then once you add too many of essentially these walls between these chains, now we can no longer form the lamellae. So what I've really probed is a system that can align nanoparticles, but that we do have some sort of limit in terms of alignment until we go from disordered at a certain loading. So this is my work with the parallel alignment. I'm also working on vertical alignment of platelets in block copolymers. And once we establish directed alignment and control over the orientation and structure of these particles, we can start thinking about how we can incorporate functional particles into these systems for our aims in REACT. So with that, I'd like to acknowledge both of my groups, as well as my collaborators in the Riggleman group, of course my advisors in France who made it possible and were instrumental in the success of my time there and for collaborations going forward, as well as Sign Center facilities for all my electron microscopy support and then funding as well. Thank you.
We have time for a few questions.
Hi. To go back to your interpretation regarding the frustration of the, so I'm going to ask a key question, someone that did that. Adding all those platelets, because you go really far, could it be just that you're moving in the phase diagram because you're increasing the volume fraction of one of the two blocks artificially?
Yeah, certainly. And that's actually something we were actually this morning talking about probing, is actually going off of the lamellar region and incorporating the particles to see if we can shift back into the lamellar region.
Or maybe change the, adopt the cylindrical
Right,
sense.
right, yep.
That's smart.
So you said you made your particles by rapid thermal decomposition. Do you want to just talk us through that?
Yeah. So I have precursors of the rare earth elements. So, for example, it is gadolinium trifluoroacetic acid would be a precursor. And so I incorporate all the precursors into solution with ODE and oleic acid. And then it is a fast ramp rate to the reaction temperature of about 290 degrees. There's a vacuum portion of that, and then the reaction under nitrogen.
So you put everything in one vessel, heat it up fast,
Yep.
and then you're done.
Yep.
Wow.
After 7 hours.
Okay, 7 hours. They're beautiful particles for something that sounds straightforward.
Do you think it's really important to have them all aligned very parallel and in one plane to get the final properties that you want? or there could be some misalignment?
I think there could be slight misalignment. I think experimentally that even in some of these images, let's see if I can go back here. There is some slight misalignment even within the domain. So that's something else I'd like to look at is the effect of block copolymer molecular weight to see how that might affect the alignment just within the domain. If there might not be more variation in terms of the angle within the domain spacing itself.
Do you have any sense of whether these morphologies are equilibrium? Well, I'm fascinated by the fact that you go from ordered to disordered with another particle inclusion, but I presume that you don't order these samples from the disordered state, like at the low volume fractions, and you don't heat to high temperatures and then come back into the ordered state. Do we know that they're not just kinetically trapped, for example, that microphase separation didn't get arrested or something because of the high volume fraction of particles?
That is a good point. We've thought about going above ODT and then coming back down. So that is a good question.
Tell them how you make the films.
So I do thermally anneal the films. So I thermally anneal them for, what was that?
You spin coat.
I spin coat them, yep, so I spin coat them. I have as cast, I've looked at the as cast samples and those are, they kind of look like the 25 weight % where everything is well dispersed. And then I thermally anneal them for several days.
But with the particles, the viscosity could be higher.
Right, it could be, yeah, things could be, I mean, changing the dynamics of the system.
And Riggleman group was doing simulations, right, with Rob.
Unfortunately,
Yeah. We will have that.
This
Yeah, we'd like to couple that with simulations.
It's a solvent casting.
Yeah, so I am spin coating.
This is not here. Nadia will be here after the symposium.
Don't indulge the person who gave you food this morning.
Okay. We're just really excited to get to the tenting presentation.
I'll ask more questions to Nadia.
So our next presentation is really exciting. You guys can come set up. We had a group of 6 students this summer. Okay, so we had a group of 6 students who did a summer project to design a tent with hydrophobic surfaces, and so this is going to be a group presentation of 2 of them, Sisan, Dorsu, and Mauricio Alvarez.
Hi everyone. Nice to see you guys again. So my name is Sisan Dorsu and this is Mauricio, and today we're missing David Gordon, Catherine Call, Griffin Murphy, and James Mischkis, and the 6 of us worked on this project together. So we worked on creating a prototype for an emergency relief tent that used active coatings to direct and collect water. And so why did we want to do this? So between 2008 and 2015, about 26.4 million people were displaced due to climate or weather-related natural disasters. And a lot of these people end up living in tent camps like these, as you can see in this image, as well as refugee camps. There are a lot of people living in refugee camps who just live in tents for months at a time, sometimes even years. So in order to get our optimal prototype, we focused on the design of the actual tent, the coating for the tent, and then characterizing the different coatings that we came up with in order to get the final coating that we ended up using. So those are some pictures of us having fun in our labs. And so before we dove right in, we got some inspiration from ShelterBox, and ShelterBox actually sent us one of their boxes, and the box had like a giant tent in it, as well as other things like the water filter system and like a toolbox, other things like that that they deployed to communities after natural disasters. So we put the tent together and we took some notes on features in the design that we wanted to take into account when we made our actual tent prototype. So this is just an image of the final prototype, and as you can see, the point was to divert the water through those channels to the corners of the tent, and we have models over there on the right side.
All right. So first, we didn't want to have to like reinvent the wheel. We know that in nature things like this already exist, and we base everything on the lotus leaf. So the lotus leaf displays a very super hydrophobic nature as well as very slippery behavior. So the water not only beats up on top of it, but also it slides right off of it at very low angles. So just a little background. The contact angle is the angle that is formed when the three interfaces, the solid, the liquid, and the gas meet. And any contact angle higher than 90 degrees is considered hydrophobic, lower than 90 degrees is hydrophilic, and higher than 150 degrees is considered super hydrophobic. We wanted our coatings to reflect this super hydrophobic behavior. Besides that, we also wanted to create a coating that will be slippery, because as many of you already are thinking, like any of our tents or any tents that you rent or buy are already like hydrophobic, like water doesn't go through. The difference is with these coatings, the water will just slip out of it, so it will be very slippery instead of being sticky, which is the current problem. So as we can see here, we measure the slippery behavior based on the hysteresis. The hysteresis is the difference between the advancing and the receiving contact angle. The more difference there is, the more sticky it will be. The less difference is allowed, then the more slippery it will be. And we want to try to like replicate the lotus again with a very slippery behavior. So how do we achieve this? Well, hydrophobicity is achieved first of all with chemistry. We have hydrophobic substance that is not going to interact with the liquid. We're going to have that hydrophobic behavior. But to reach the super hydrophobic behavior, we want to try to mix the micro and nanoscale roughness to achieve these little pockets on the Cassie state that will allow the water to just slip right off. Here we can see how the lotus leaf actually has that micro and nanoscale level of roughness to achieve this behavior. And here we can see how our coating actually reflected that, which we'll go more into later. So we wanted to create a coating that was scalable, something that we can create in big amounts, and that is not going to be harmful to the environment. Hopefully something that we can disperse in water, and also something that is not only displaying these characteristics, but it's also displaying it over a long period of time, and that it can resist like you scratching it or washing it, so that it's durable and keeps showing these characteristics. The final coating method that we decided to go with after trying many coating types was graphene nanoplatelets. The reason why we decided to go with this is because it was dispersible in water, so we didn't have to use harsh solvents that would contaminate the water. And we ended up using 15 coats because any less amount than that was not producing super hydrophobic results after being rubbed, and any more will just be wasteful. This is the graphene nanoplatelet. As you can see, they are pretty hydrophobic, and then as they can like get on top of each other and like stack, they can create that roughness that we're looking for.
So we characterized the coating samples that we made, and so with this image on the left, you can see the uncoated PET fabric, and you can see that microscale roughness developed by the weaving pattern of the actual fabric, and then on the right, you can see the fabric with the 15 coats of the graphene nanoplatelets on it, and you can see these nanoscale roughness features. And this is a closer up SEM image of that. And so the contact angle of the actual uncoated PET fabric was already pretty high, but when we coated it, you see the increase in the contact angle, but more importantly, you see a significant decrease in the sliding angle, which means that So when we coated it, it became a lot more slippery compared to the uncoated fabric. And so that was the more important achievement with the coating. And so we ran into an issue, a challenge with the adhesion of the coating. We noticed that, if you just like rubbed on it with like a glove or something, some of the coating would come off. So we ran a bunch of adhesion tests, such as running it underwater, sonication, taking off with tape, rubbing the coated fabric with itself, just self-friction. And so you can see some microscopic images of the different samples. And then...
So here we can see that after adding that base layer of cement, before adding the graphene nanoplatelets, we were able to maintain the functionality even after being rubbed. Again, the main problem that we were having is that this is the uncoated fabric. Just coating it with graphene, we were getting that super hydrophobic behavior, but as soon as you rub it or wash it, you were coming pretty much just back to the basic, right? So you were losing those properties. After adding the cement, before adding the graphene, we achieved that super hydrophobic nature, but even after being rubbed, we maintained that super hydrophobic nature, which is what we wanted to do, something that is durable. And it's also replicated with the contact, with the sliding angle and the hysteresis. So again, the fabric by itself, it had a slight angle almost 90 degrees, so you have to be almost completely orthogonal to like slide right off. Adding the graphene, you go back to less than 10 degrees, so it's very functional. However, if you rub it, you lose all that. Now, going with the cement and graphene, we can see that the cement is helping the adhesion, but it's not compromising the functionality. You still have that sliding angle very low. And once you rub it, you do lose something, but you don't lose as much as without the cement. And here is why you lose some of that sliding angle, is because by being rubbed, you kind of like lose some of that extra roughness, as you can see here.
So if we were to continue to optimize these features, we would look into making the coating solution more durable and exploring other types of adhesive layers that we could add in between each graphene layer, as well as making this easy to mass produce, because this is a time-intensive process. So you had to coat the graphene, put the layer of cement, heat it, another coat. So we had to do that 15 times. So if we wanted to actually see this mass produced, that would probably be an issue. And now we'll go into the structural design of the tent.
So besides the chemistry and the science, we also needed to make sure the tent was functional and it's going to be easy to deploy. So the main thing that we work here, we want it to be something that's pretty like self-explanatory. You can deploy very easily. Also, we wanted to have a tent that is customizable and modular, meaning that you can take different or like many tents together to create different usages. As you can think, people don't need to always be living in a tent. You can get 3 tents together to be used as just water storage, and different usage for our community that we can think of. Again, the easier that it is for a person to use, the more likely it is that that person is actually going to use it that way. Another good thing that we thought about is ventilation for high humidity places, or places where it's very hot. We want to have people to be comfortable living in there. And lastly, and the most important thing, we wanted to make sure that the design of the tent itself is useful for these active coatings to be able to channel the water. We decided not to coat the entire tent with the material, even though we did increase the durability of the coat. We didn't want to have too much rubbing between the coat, because it doesn't matter how well you do it or how much you put into it, it's still going to be losing some efficiency as you rub it. So we strategically place the coats only in the black seam, so everything here that is black is actually coated, and that's where the water will be falling in from the rain, and it will be directed to the sides of the tent, where it will be stored for different usages. How can you use it? Well, we can either in future projects we can incorporate a filtering system, or we can use existing technologies such as live straw for us to be able to retrieve that water efficiently.
So just to wrap up what we did within our summer to actually get this prototype, we had to develop the coating, which was spray coated onto the PET fabric to change the wettability features and the chemistry, and to obtain that hierarchical roughness structure. And then we tested these coatings and characterized them using microscopy, SEM, and goniometry, and then ultimately we came up with a design that complemented the usage of these active coatings and the direction and the channeling of this water to be ultimately filtered at the end. So we'd like to acknowledge everyone that helped us through this project. We have our PI, Dayon Lee, our faculty advisors, Orkan Telhan, Russell Composto, and Zara Bakrai, as well as our graduate student mentors, and then our funding from the Krook Surge Grant, and REACT, South Pyre, and of course ShelterBox for giving us some of that inspiration.
Thank you.
For one or two very quick questions.
I can speak super fast. Thank you, Zach.
What's your speak as long?
So you looked at durability, you improved the cohesion of the coating with the cementanol, but do you know how it would resist the ice forming during the night? Like if it were to rain at night and then the ice forms, instead of just running off, how would do you know if it would resist?
So one of the main things by having these low sliding angles, or the low hysteresis, is that water will not collect. And this is very important because besides preventing like dirt to be accumulating, it also prevents the water itself to accumulate. So there will be no water left over there to freeze. So as far as the coated part, there will not be ice in that.
Okay, let's thank the
Okay, so it gives me a great pleasure to introduce our very special speaker. He's so special that the university let us take the afternoon off so that we can all be here without worrying about our work. His name is Bill Decker. Bill is a trustee, wears many hats. He's a trustee at ShelterBox Trust in the UK, and also was the past chair of ShelterBox USA. As you know by now, ShelterBox is an international humanitarian relief organization that provides emergency shelters and supplies to people who have been affected by natural disasters or man-made crises. So Bill, while he was the chair, oversaw huge expansion of their activities after the huge earthquake in Haiti. For the work that he has done, he's received, I want to get this correct, President's Call to Service Award, which I believe is the highest level award that is given by the US President to people who are in the volunteering work. He's also received the Philadelphia Business Journal's top 40 under 40 list. Number one, he's a great businessman, and number two, he's young too. Very inspirational. So he's going to talk to us about some of the activities that ShelterBox is doing, and how what we are doing could be relevant. So please welcome Bill.
Thank you. David, I probably should have said that 40 under 40 award was awarded 20 years ago. I should have 60. Thanks so much for the introduction. And wow, what an inspiration to be among all of you today. Just going downstairs with the poster presentations and the enthusiasm and the excitement of some very bright people that are working on some very relevant problems. And I am just so excited about what I saw. I'm actually going to write an email this afternoon back to the UK to say that we're about 6 months off from the dream tent. Just kidding. We've got a few more years, right? But it's fantastic stuff, and the future is bright. So today I'm going to tell you a little bit about ShelterBox beyond the basics. Give you a little bit more idea about what we actually do in the field. As I understand it, that's what we're looking for here. We're looking for some framing, so we can see the boots on the ground sort of aspect of what we do. This talk will, there's one common thread that's in the room today that is very evident, and there's lots of talk of water. So we're going to take it down that path as well as we go. As mentioned, I am a trustee for ShelterBox. I'm also a field volunteer, which is a pretty important part of this discussion. I've been deploying to natural disasters around the world since 2007, and have been to some pretty interesting places, dealing with some pretty big ones, including Port-au-Prince, Haiti in 2010. There we go. All right. So, founded in 2000 in the UK, 250 plus disasters around the world, 100 countries, more than 100 countries. We've provided shelter to more than 1 million people in that 15-year time frame, as well as developed a global volunteer network. So we have volunteers around the world, like me. There's about 280 of us that go on call to be deployed to a disaster zone at a moment's notice throughout the year. And that's our primary delivery method for our aid around the world, is through this volunteer network, which makes it truly unique among NGOs. We do have professional staff that help us to achieve what we do with logistics, etc. But we really do lean on these teams of 4 people that we send in to try to make things happen. And a little bit about how we do that. Typically we have a disaster, we get a phone call, and we send 2 people in really quickly to go and determine whether we can make a difference. Are we going to be relevant, and do we have capacity to deliver something that's meaningful to our beneficiaries in these affected places? If the answer is yes, we oftentimes have pre-positioned stock around the world in warehouses that we allow us to get places really quickly. And that's what we do exceptionally well. That's what our donors love, is that we can be on site and quick to respond to things that happen. So you can see 2 pieces of our kit right here. We call it kit, that's a UK term. This is called a shelter kit, and this is a shelter box. And right here is the actual tent that we use. And I was sharing a story earlier about how these things have evolved over time, and I'll tell you a little bit more about that. But you can see the elements here, one being a really high quality set of tarpaulins, some nails and a hammer and some rope and some implements that really helped somebody to repair an existing structure. Oftentimes what we found over the years is that we had this one-stop shop solution called a tent, and we would show up in a disaster, and if our tent didn't really fit the disaster, we couldn't really help anybody. And we'd take our tent elsewhere and go do something else. Over time, we became less product focused and more services focused. How can we make a difference? What sorts of things can we do? And that's how this shelter kit developed. I just delivered 1,000 units of this in May to Peru to a flood situation, and incredible impact and exactly the right thing, because people's primary structures were not completely destroyed. ShelterBox, you can see our water purification, which is called the Thirst Aid Station. Some ground sheets, there's a mosquito net right there, some cooking utensils, and some more tools, children's activities, and actually a Luminade solar lamp. So it's very thoughtful the way that we pack these boxes. We don't necessarily send a mosquito net to North Korea. We've done a lot of activity in North Korea. It's something we don't talk about publicly. But it's freezing cold, and we don't need to deal with mosquitoes in North Korea. We have a lot of other things to worry about. So that's kind of the nature of our package. We do have a partnership with Rotary International, which I should mention everywhere I go. It's 33,000 clubs, 1.2 million people around the world, and an incredibly powerful civil volunteer network, civic volunteer network. I haven't deployed once to anywhere in the world where I haven't leaned on our resources and our friends at Rotary to help us to deliver what we do. A little bit of imagery of what the tent might look like in the field, and another just straight up picture. If you're a tent geek like me, you can appreciate a lot of the really cool features There's adequate ventilation, it's waterproof, it's windproof. I've lived in this thing in some very bad places for periods of time that are probably too long. And it's a tent geek's dream. Pretty much the finest piece of tented shelter that's available in the world. And here's an application of the shelter kit. You can see here, it's the spirit of it is so different. We're taking local materials, there's bamboo structure under there or some other locally procured wood, and we're using the materials that are in a shelter kit to actually rebuild a structure that may have been destroyed. This was in Peru back in May. And to really implement these as well as the tents, we spend a lot of time as field volunteers training people. We kind of are almost professional trainers when we go in the field because we have to find the centers of gravity in these villages and have them be taught, typically by their own peers. So we do kind of a train the trainer. And then we hand out this aid and we go and monitor them for days afterwards to see if they're implementing it correctly, offer them some guidance and coaching and things like that to make sure that it's doing what it's intended to do. So now let's get down to the nitty-gritty of natural disasters. And unfortunately, it's a growth market. It hurts to say that, but it is. It's up 80% over the last 30 years over the previous 30-year mark. And you typically have about 26.5 million people who are displaced annually in over 100 countries. The numbers to talk about also involve the affected population. So an affected population is, it might be, I was in the Philippines in 2013, and the tidal surge came in and flooded all the freshwater wells with salt water. So that population may not have been displaced, they still had their houses, but their water was ruined as a result. Man-made disasters, unfortunately, on the rise in recent years, and 300 million people globally live in that what's labeled as violent insecurity as a category. And Syria alone is its own incredible tragedy. There's really no place in the world that's not touched. The empty spots here are ones that just generally have no or little data to report, typically. And one of the most interesting parts being the United States ranking so highly with its incidences. But you can see it's a world of disasters, and this is probably the most telling, and I think the one that drives a lot of the numbers that we're seeing, and that's that really it's totally most of the growth that we're seeing is through meteorological, hydrological, and climatological events, and you can see over time the trends are pretty clear that all three categories are on the increase, and the severity too. So this is Typhoon Haiyan in 2013. At that point was the single largest storm in recorded history to hit landfall. And we're seeing more and more mega storms, superstorm sort of situations that have pretty wide-reaching effects and displace a lot of people all at the same time, which puts tremendous stresses on our systems. And that's why when we start talking about solutions to problems, we really do talk a lot about scalability of them. Some of the stuff that we might see in the field, more images. This is Port-au-Prince, 2010. It looked like a nuclear bomb went off. Pretty stunning in what we discovered when we got there. Some of our teams you might see in these villages. This is in the Philippines. Just doing assessments and trying to figure out where are the beneficiaries, how can we help, and with what type of relevant solutions. So now let's move to the big picture. It's water, the common thread that we're all seeing here. And from a general standpoint, independent of the natural disaster world, it's just a problem. So we have 2 billion people in the world that are drinking water that contains trace feces. By 2025, we have half the world's population in water-stressed areas. And really one of the saddest things is we have these preventable diseases that are largely a product of the lack of sanitation and fresh water. 525,000 deaths per year for children under 5 just from diarrhea, all preventable. So really interesting watershed in 2010. The UN General Assembly recognized that it was a human right to have access to adequate water and sanitation. And the world has responded. You see a lot of the sphere standards that we use in our industry governing how we react and respond, moving in that direction to say, all right, we need solutions that are integrated and relevant to these disasters to help folks. Now the other part of this too is just the concept of access. So you have all these people that have access to water, even if it's kind of slightly polluted. You have about 660 million people that don't have immediate access. So they're walking 6 kilometers to go get their water. And unfortunately, typically these populations, it's the women and it's the young girls that are having to go fetch the water at that average distance. And we're talking up to 45 pounds of a load. So imagine what that does to a young girl's body when she's walking back and forth. Not only is she missing school, she's physically degrading herself, and she's exposed to other dangers along the way, be it lions, tigers, bears, people, whatever it might be. So there's definitely a loss of education and a gender discrimination piece to this. It's kind of, when you start peeling back the layers around these truly global problems, you really start seeing the depths and the effects that you have across populations. So now when we get to a disaster zone, this is typically what we see. It's a lack of fresh water. It's the proliferation of all your standard pathogens, cholera, dysentery, polio, typhoid, dehydration both in the population and in the people who are there trying to help the population. And we see infection rates skyrocket because of the medical implications. And this quote, I think, says it all right here. Diarrhea is a leading cause of death during complex emergencies, natural disasters. Displacement of populations into temporary overcrowded shelters is often associated with polluted water sources, inadequate sanitation, poor hygiene practices, contaminated food, and malnutrition. And that's really, I think that sums it up. And there's not one disaster that we've responded to where this has not been a problem. And now, safe water concern is just at the forefront of everything that we do in disaster response. It's a top concern immediately following those sudden onset emergencies. And it remains a persistent concern throughout the response and far beyond oftentimes, because existing infrastructure may be permanently damaged and there's no backstop solution. And because each emergency is so unique, there's really no specific silver bullet that really attends to it. And there's all these bulk solutions, chlorination, distribution by tanker trucks, and point of use solutions at the household level. They're out there. Unfortunately, we really haven't seen anything that is that awe-inspiring in terms of its widespread capacity and capability. I mentioned sort of the healthcare aspect of things. In Haiti, every hospital was destroyed without exception in that earthquake. And we were using ShelterBox tents, in fact, for field amputations down at the right on the tarmac of the airport, because that was the only place we could set up field hospitals. And our lack of resources meant we were seeing 97% infection rates in patients that were mostly having amputations because of all the crushing injuries. So this is pretty key to the way that we look at problem solving at ShelterBox. And first and foremost, we use a structure that is based around something called theory of change, which some of you may have heard of. It's kind of, I think it's more of a Eurocentric thing. But really, at the end of the day, it's focusing on what the outcome is that you're looking for and sort of working backwards from there. It governs every action that we take at ShelterBox, with the beneficiary clearly placed at that end of that theory of change to say, okay, what can we do to make a short-term, a medium-term, and long-term impact, and how do we do that, and how do we monitor that afterwards and report back to our donors that we are good stewards of their dollars and their pounds and euros. And as we look at solving problems, this is really central to it. So we can talk through a little bit of it because I think it's relevant to exactly what's happening here. The problem, typically we think we know. but we don't always know the problem as we should. So I think Haiti is a great example of that. And I mentioned earlier how we evolved to have this shelter kit and this tent concept sort of side by side. Haiti was an urban disaster. It was piles of rubble all over the place. And a tent footprint is 14 by 14 feet. And you're going to have to put people generally in settlements or encampments when you provide them with tented shelter. Unfortunately, Haiti has, so we think we have a problem in that we need to provide shelter for people. We think that's the problem. But what we learned was that property ownership rights are not transparent in Haiti. And to take somebody from their pile of rubble and relocate them to a camp means that they're leaving their only assets behind, whatever it is. Their pile of rubble might be all they have left, but at least it's their pile of rubble. People were going to the encampments at night, and then they were coming back during the day to stay on their property just to watch it. So had we had a better solution, a more appropriate solution, like the shelter kit, where they could kind of go and clear some of their rubble and kind of rebuild a little bit of their structure using the shelter kit, we would have helped solve the problem both of providing shelter and seeing to their security going forward. So that's an example of really understanding that problem and asking lots of questions around it. Next we have process, and I put not product under there just to make sure that we all understand that process that ShelterBox went through, becoming more service focused rather than product focused, is critical. The process by which people find, transport, clean, and we'll use water in this case, is absolutely critical to the success or failure of a proposed solution. And the process has to lead. And we learned that at many different phases in our existence, and that's part of our own internal Bible, so to speak. One thing that we have to pick up along the way also are cultural influences. And they can be wide and varied. One of those that I would point to would be chlorine tablets, for example, are a great way to provide some clean water to folks. Unfortunately, some cultures believe that chlorine tablets are an attempt by Western forces to sterilize them. So that solution is not an appropriate solution for that population. Oops, sorry. We move into the solution phase, and we have to recognize that people don't change behaviors very easily in traditional cultures. They don't change very easily in Philadelphia, for gosh sakes. I lived here for a decade. It's just not in human nature to want to change the way you do things, and especially on the worst day of your life, when half your family just died, you lost your house, and now I'm going to try to tell you how to cook your meal a different way. It just doesn't take. So when we talk about solutions, we talk about simplicity. And there's a huge drive in our sector right now towards simplicity. Simplify everything. Don't make it hard. And we've learned over time that we would come up with a really awesome solution. We used to have a Frontier stove, for example. It was a wood-burning, high-efficiency stove that we would put inside that ShelterBox. The problem was that nobody wanted to use it. They wanted to do things the way they'd always done things, and especially in this environment of a disaster, it just didn't work well. And then we get to the benefits, and the key with our benefit under any circumstance is, does the end user understand what that benefit is or what it's supposed to be? Because if they don't do that, if they don't understand that, nothing prior to that matters. And sometimes that's pretty difficult to communicate. This is better for you because I say it is. That doesn't always fly either. So there's sort of an educational piece of it that's very important, and that's where we co-opt a lot of our local populations, some of our implementation partners, to really help us to communicate those things to our beneficiaries. And for us, back to the outcomes, I mean, that's the reason we're doing what we're doing. When we measure our success through monitoring and evaluation, that's where we're headed. We want to know what our return on our donors' dollars are. And if it doesn't look like it's a good 1 to 3 sort of ratio, we actually will not deem it as a success. So since we're talking water, we can look at some of the current solutions that are out there on the market. I'll just preface it by saying every one of them is wholly inadequate, and that's why this is such a huge gap, and why I'm so excited when we talk about some of the possibilities to profoundly change the landscape around this. There are basically 4 types that are out there that are mainstream types of water purification that happen at the household level, and that we've grappled with throughout the years. You've got ceramic solutions that are ceramic filtration. You've got membranes, which actually you can see here, that's a membrane solution there. We have biosands, which are pretty interesting themselves, and then we have chemical. And as I mentioned, not a one is appropriate. This is the thirst aid station that I mentioned earlier. We use this now with ShelterBox. I field tested it. It works okay, but it doesn't check off a lot of the boxes that we have. So when we talk about those boxes, and this is where it starts to get interesting, that the sector itself, NGOs, et cetera, have gotten together into a working group through the Humanitarian Innovation Fund, and have taken a really strong look at this. And some of our technical people in the UK are involved in establishing what does success look like for these types of solutions. And it's pretty exciting to actually have this dialogue going on, because it is such a significant unmet need. So we look at 3 categories: logistics, ease of use, and performance. And of course our solutions in there in the wood pile right there. So let's talk about some of those. Simplicity of use. As I mentioned earlier, you're dealing with people who have had something very tragic and horrible happen, typically, and if it's not simple, it's not going to be effective. Maintenance and cleaning, other pieces. You can't give somebody a little calendar with a red dot on it to change their Brita filter 3 weeks into the disaster. It's just not the way that behaviors go. Embedded instructions that are knowable and understandable across language barriers. A lot of visual type stuff is what we look for. It's got to be portable, because sometimes you're dealing with populations that are on the move, and it's hard for them to take anything with them, and it has to be essentially zero energy required to operate. Now there may be some solar solutions that are kind of coming along out there, but they're not practical as of yet for this type of an application. Performance, nothing less than 99.99 on both protozoa, bacteria, and virus protection. We have the technology now, and current solutions can do that. Flow rates, this is one of the biggest ones. If you can't produce 20 liters in 12 hours, you're not even in the ballgame. And I think if somebody can crack that code on flow rates, it would be it would be a game changer, I believe. Taste and clarity. We all deserve to have water that's palatable. Lifespan, we like for it to last for a year. We like for it to be robust. We want it to be able to function under challenging conditions. If it's too flimsily put together or requires too much tinkering, it's not going to be functional for us. It's got to cost less than $20 per family of 5, and we do expect that 1 year of use. This image, actually, I think I'm on this boat somewhere. It gives you an idea of what we have to go through to be able to deploy aid. Sure, we have a C-130 that brings all the aid into country, but once it gets there, we end up in some pretty remote places, and we have to use a lot of different forms of transport to get our assets into the right places. So packability and weight, and they have to be sustainable is another big one. You know, our sector used to not really care about that. Because it's a disaster situation, it doesn't matter, forget about it. Let's send in thousands of pallets of bottled water and exacerbate the already horrible plastic bottle situation that exists in many developing countries. And now there's a turn towards more sustainable solutions. And then that durability that allows for it to be transferred thousands of miles and put on the back of a mule and brought to the end user as a beneficiary. So back to the current solutions, and you know, there's easily 100 solutions out there on the market. The group that we're working with is looking at 34 different solutions. They all pretty much are doing very similar things. But when you think about those criteria that I just provided, you can start picking apart every single one of them. This one comes as a regular bucket and requires that you drill a hole in it and then install a spigot and then do some caulking around it. All of those things I find in disaster zones all the time. I mean, I got a drill and caulk right there in my bag. So not practical from that standpoint. That's a ceramic use. Membranes, and this is actually this product we used to use at ShelterBox. It was the predecessor to the Thirst Aid Station. Membranes are notorious for fouling up. They have to be backwashed all the time. They are effective from a disease management standpoint, but super high maintenance. And one thing that I saw in the field was this little red bulb here and this little red spigot is where all the dirty stuff's supposed to come out. The clean stuff comes out of this spot right here. But in the field, when someone starts using it, I saw beneficiaries pouring the water out of the red spot. So when it gets to the point where you think you're probably doing more harm than good to an affected population, it's time to reassess. And the deal is that these are made by some very clever people, right? But the beneficiary is not as sophisticated as that person that created it in general, or they're under duress and they're adequately stressed to not really be able to follow the directions as well. So back to that idea of simplicity. This is biosands. I can't think of one disaster zone I've been in where I would have wanted anything to do with the sand under my feet, much less as a water purification tool. So you could ship sand into country. I got a lot of laughs on that one, right? Like, what other things could you send instead of sand that would be more relevant to these people? A bag of rice, for example. I mean, how could you consciously send sand? I mean, it's a PR nightmare too, probably, if you did that. So you can't do that. This is a ceramic solution, low volume, and then we talked about chemicals. So I hope that I've been able to impart upon you the wholly inadequate solutions that are out there in dealing with this the problem of water. I call it the problem of water because it is. And the profound difference that can be made by just solving some of these little things. Collection and storage and purification. All these things that are kind of these common threads in what we've been talking about here today all offer us this opportunity. So what do we like about advanced materials? Well, we see that very high potential flow rate. We see the light transportability, and I'll encourage tarps over tents just because when we're in a disaster situation, we need to get things in really fast and not worry about customs as much, and in a very simple material product that's flexible and easy to deploy, we can do a lot of good very quickly with that, and the tents can follow. But focusing just on the quality of the material itself, it's flexible, it's simple, and it's incredibly scalable, assuming that we can get the numbers to work right. And then we have our howevers, which of course are costs, which, you know, I think we all recognize that super hydrophobic with 15 coats is awesome, is gonna do some cool stuff. But if we can't commercialize it to be able to build it economically for less than $20 per household, we're not gonna be able to do much. And then considering those three main things, when we go back to process, go full circle to process, how do people gather and use and clean and consume? How do they put it in catchment, channel it, and vessel it? all another part of that supply chain from when it drops onto that material to when it gets into somebody's belly. So concluding, I hope everybody can appreciate how much this matters. And I hope that my excitement for this is evidence to you of that, because I have seen a lot in the field. And when somebody talks to me about these types of solutions, I can see the other end of the tunnel. I can see that light, and I can see a future that is an enhanced future for a lot of people. We're talking about billions of people here. These are no small tasks, and the benefits that can be gained from the world around us are clear. We have better health, a better life. You know, when we talked about school attendance and education and what keeps kids out of school, oftentimes illness because they have crummy water, besides the disaster aspect of it, or the girls that have to go fetch the water every day. Positive longer-term outcomes, and that's really why we do what we do. Stronger, more resilient communities. Did we make a difference? Did we help the recovery of this group of people to the point where they're going to be better off in the future because we helped them? It's a pretty simple way to measure, but it's real. And for that, I thank you. I thank you for your efforts. I thank you for your tireless work. I'm sorry I didn't put any molecular chains up here for you to analyze today. I figured everybody else took care of that part of it. I hope you got a good view of what we see, sort of boots on the ground, what the current landscape looks like, and an idea of some of the problems that you're solving. And at that point, I'll take any questions anybody has.
We have plenty of time for questions, so Nadia?
Thanks for a very eye-opening presentation and discussion. I have two questions. The first is regarding the water problem. At what price point, if any, does a solution exist? So I mean, there are many characteristics that you have to hit with the solution, and cost is one of them. But if you eliminated cost, or if you just went up steadily in cost, is there a price point at which a solution does exist, and then can that cost actually be scaled down? That's the first question.
Yes, I don't see a solution in the current landscape of product that's available that that would allow for that in an immediate response. If you have time and a high budget, there's all sorts of solar distilling machines and large infrastructure type projects. The Germans are work on that in most disaster zones, but that at the household level, day-to-day mobility.
Use portable.
Yeah, there's tons on the market, and the working group has established that it's desirable to have that at $20 per day. Ours is $23. I'm sorry, not $20 per day, $20 per unit. Ours is $23, and there's the UV pens that are out there, right? That are $200 and something a piece. But when we put that up against our criteria, it doesn't pass muster because it requires batteries. Number one, like, we're not going to put a product in the field that requires batteries at this point, because it's going to be dead in a matter of days, and they're going to have a useless piece of equipment on their hands. So that's striking that balance. I know where you're going, and I wish I could say there was something that's $2,000 a unit that we could put in people's hands at some point. If we can produce enough units of it, then the economics work, but it's not there.
And then my second question was just a clarification regarding some numbers. At the start, you had some statistics that stated that there's an 80% increase in natural disasters over the last 30 years or so,
yep,
relative to the previous 30. That number struck me as unusual.
Yeah, I think there's a few pieces to those numbers. One is we have increased urbanization to the coasts globally, so our population densities are greater in these bigger coastal cities, and they're more subject to typhoon and flood so I think we're talking about impacted populations. Right. When is a disaster, right? A natural disaster, it has to affect the population in some way. And so as you see that happening, I think, and there's also better reporting probably than there was back in pre-1980. We have Greater Global Communications, we can actually see from a satellite that there was a significant event in Namibia that no one picked up the phone and said, hey, we had a disaster in Namibia.
And you also showed a slide that reported that the highest density of natural disasters was in coincidentally, the three most populous nations on Earth, China, India, and the US.
Yeah.
And that's not by chance, I don't think.
No, I don't think so. I think when you're talking about affected populations and combined with monitoring, you see an increased reporting. It's kind of like epidemiology. You see increased incidences of autism, for example. And is it just more frequently reported, or are there more autistic folks in the world? Yes.
You mentioned that solar is not a solution. Can you elaborate on that?
Just that solar. There hasn't been anything that's come to market yet that that delivers that using that technology. So we could say, all right, we could use the UV treatment that requires batteries. We could augment that with some sort of a solar solution. Then we get into the idea of something being complicated, that ease of use hurdle that I talked about. We have solar lamps that we use, the Luminade lamps. You may have seen it on Shark Tank. It's a pretty cool episode. I have a hard time getting people to understand how to use those in the field. And it's just a simple solar lamp. That's probably the bigger challenge. But something someday, I think, with advances in solar technology, it's going to come to the table that will be viable in some way. Will it be something scalable and meet all the other criteria that we've established? I don't know. I hope so. Yes?
A question, is there a solution for all disaster, or do we have to really work case by case?
You're saying, is there a blanket solution that could be?
Yes. For example, imagine a solution for all type of disaster, or is it not possible? And do we have to really constrain the conditions?
Yeah, I think disasters. I've never been in an environment where it was exactly the same both times, and sometimes the solution. Solutions that I've seen for water, for example, were not ones that would be appropriate in another situation. Like when we had the flooding of the water sources in the Philippines, and they had seawater in them. So some of the others, I couldn't put chlorine tablets in there and make that water safe to drink. So that's the unfortunate part. I wish there was a silver bullet where, we could say, hey, that's applicable. And some of the stuff that we're talking about here starts to get into that neighborhood. So it's possible, but the current landscape tells us that there's no silver bullet, unfortunately. Yes?
I have an education question.
Okay.
So I see a lot of applications to Penn, and I think we have students here that really want to truly save the world.
Yeah.
They don't know how to do it. They know there are serious problems out there. Educationally, what are things that our students should be thinking about more broadly than the STEM education? Denis' favorite thing is insurance, is policy, there's economics, there's all these other issues that you kind of touched upon that play a role.
Right.
So do you have some suggestions both on the education or the exposure side that our students should be thinking about to prepare themselves to attack these problems?
I think if you're looking at global problems among affected populations, educating yourself on what's happening in these cultures, it's part anthropology, it's part linguistics, it's part religion. I mean, there's so many pieces that feed into how these things play out in these environments. And when you have 190 plus countries around the world, it's hard to keep track of all the little moving parts. So, I'm a product of a good liberal arts education, and I think that's benefited me in how my mind grapples with some of these things. I wish I could meld myself with an amazing scientist like some of the folks in this audience, and we'd probably win a Nobel Prize or something. So that would be my recommendation: is to broaden your exposure. We take people as volunteers into our organization from all backgrounds to go do the field work, because there's really no specific skill set that arms one to be able to effectively deliver aid in the field. So I think that's kind of testimony to what it is to be a global citizen and really dedicate yourself to not only being excellent at your trade, but being a conscious global citizen. Yes?
The volunteers that you bring on site are trained ahead of time through ShelterBox and through your training program. And my question is, what about if you had occasionally a person like someone in this audience as a team member who can observe, who's going to learn from, you know, the challenges? Like you said, you can't meld a scientist to you maybe, but maybe you could, you know, change your method of teamwork so that you could take a specialist that needs to solve a problem along as an observer.
Yep.
You know, and do you do that?
We have done that in the past. It's usually as a donor development sort of a thing. So there was a Microsoft guy last year that donated $1 million to ShelterBox, and so we took him in for a field experience as a very exceptional thing. What we typically do is run our volunteers and some of our donors through a simulated experience. We have a ranch in Texas, as well as a program in the UK that we'll run folks through. One reason that we can't just take kind of an observer into the field typically is our insurance doesn't cover us for taking somebody who hasn't been through all of the rigor of the training out into a disaster zone. The liability, there's just negligence if you end up with a serious issue. I wish we could. But there are opportunities to get close to that, I'd say, in the experience. Yes.
So one of the difficulties I know in more recent natural disasters is that people are being put in shelters that were meant to last only a few months, but they end up living in for years. So I guess my question to you is, I know it's kind of a universal question, but how do you modify your more short-term tents to be available for long-terms if you do that?
That is typically that's done at the local and individual family level. We are correct in that the tents are designed to last 6 months because they're considered an emergency shelter solution. The next phase after that is called Transitional Shelter. And so there'll be resources typically brought to bay either by government, other NGOs, et cetera, that will typically move somebody forward into a structure that is typically made out of corrugated iron, CGI, and locally procured timber. So we'll take shelter kits into Haiti. We've done it a few times because we did 1/3 of all the tented shelter to Haiti in 2010. There's tens of thousands of ShelterBox tents all around Haiti, and many of them are still in use. And so when we went back for Hurricane Matthew, and we've been back on a few occasions, we'll take tarpaulins and shelter kits and redistribute them sometimes to beneficiaries in recognition of that safety net hasn't followed up. Another thing that we do is if we receive donations specifically for a disaster, we did this for the Philippines. It was designated restricted funding for the Philippines. We had about $1.5 million left over after the emergency phase of the response. We're not going to keep putting people in tents once we're past that emergency phase. So we went to Catholic Relief and donated $1.5 million of our donors' dollars to them to do transitional shelters because that's what was required at that point in time. It's a very difficult line to toe because it's are you in the business of emergency response or are you in the business of development? And for an NGO, it's very important to always understand what your true north is and keep coloring within the lines because that's what you do well and that's what you're pitching to your donors as this is the impact we have, this is what we do. But also use any additional funds responsibly and try to have an impact on that transitional phase if conditions permit.
So shelter is critical in immediately following disasters, but so is food and security and communication. So how did you all decide to do shelter?
That's a great question. ShelterBox came about because there was an unmet need in the world of international aid. Our founder, who was a rescue diver for the Royal Navy in the UK, in Cornwall, I think he was watching CNN one day and just kind of realized that, gosh, why doesn't anybody focus on this? Why isn't this an expertise of anybody? And that was the nexus of it, was just to really go down that road. And to partner as needed, or actually we have MOUs with quite a few NGOs now, to partner with these implementing partners along the way. So we do NFIs, which is non-food items in the business. Oxfam is great at food. So let's call Oxfam and have them deal with the food. And then we don't do sanitation, but Red Cross is really good at that. So I mean, we literally will go in, there's this thing called the shelter cluster and the wash cluster for sanitation, water and sanitation. And all these NGOs now get together in country, right there, and say, all right, this is what we're working on. What are you working on? Who's taking a helicopter up into the hills today? That way we, instead of taking 2 helicopters, we'll take 1. And that system didn't really exist in 2005 when the tsunami hit. And it's really a product of post-tsunami world. And it's been tested a few times and developed along the way. In 2010, it wasn't perfect yet for Haiti, but it's pretty robust now. And so that's how you fill those gaps, with making sure that you can bring those other solutions to the table.
Actually, that goes exactly to the question I was going to ask, is that as NGOs who immediately respond to emergencies, you guys probably know where the high incident or the really disaster-prone areas are. Do you, talk to the policymakers or other NGOs who are more focused on prevention-related solutions? And do you have any impact on actual prevention technologies for these areas that are especially prone to repeats of disasters or are violently unstable for long periods of time?
Yeah, that's another great question. I think the Philippines is a great example of that. I was sharing earlier, they see 19 major typhoons per year in the Philippines. In terms of prevention, poor people live in floodplains in developing countries, unfortunately. To have an impact on property ownership rights at the social level in most of these countries is it's something that happens organically, in theory, or with some significant influence from UN, other outside organizations. We let them kind of handle those pieces of it. We do from a prevention or a mitigation standpoint. And the Philippines is a great example for this because, one, we will donate tented structures to a municipality, and they're deployed to the people while they need them, and then they take them and pack them back up for the next disaster. So we try to create some sustainability. We don't do that everywhere in the world. That's an exception, primarily because that asset, once it's donated, is the property of that family. But we have trusted partners in the Philippines that we can do that with. It works pretty well. In terms of other places in the world where we may be able to replicate that sort of model, Philippines is still part of that discussion because we now have our own internal, we have an affiliate in the Philippines that has its own operations and response teams meant to help their own nationals. So we're generating this model that is, we hope to be a more sustainable model, a more cost-efficient model. And you can start to get into, when you're organic like that within the landscape, because we don't have a country office necessarily in Burkina Faso. We just show up to Burkina Faso when it's time to react or respond. But we can get more ingrained in those cultures and be a part of that dialogue. I think that's the future, and it's a great topic. Thanks for asking that. Yes.
So you mentioned that when a disaster hit, you send 2 people in from ShelterBox right away to assess the situation and whether you can help. Can you talk a little bit about which scenarios? What are the criteria for being able to help versus scenarios that you decide ShelterBox cannot do something?
Yeah, the one major one is that we have to be invited into the country. The government has to say, yes, we want you to come and have a look, first and foremost. Secondly, then it moves into another plan. Let's work on our government relations side and building relationships so that we can make things happen faster, which is a big part of what we do now from our own internal diplomacy. And Peru is a great example. We had the First Lady of Peru facilitated our entire last deployment because otherwise it's impossible to do business in Peru. It's a snail's pace. Yes?
I have a question regarding the people who join you because I guess it's very challenging emotionally to do that, to be a volunteer. Is there something specifically that you look for in the people that join you to really do that?
Yeah, we were talking about this earlier about kind of the recruitment strategy for our field ops, and it used to be that we looked for these kind of type A gung-ho military types, and we realized that those didn't necessarily make good teams because you needed some active followership to go with the leadership and situational leadership, because you might be an expert in something that I don't realize it, but if I'm not co-opting your talents because I'm being an alpha gung-ho guy, then we all lose. So we really changed our recruitment strategy to be based around self-awareness, and it's such a simple thing, but we found that self-aware individuals, it's kind of a loose term, but I think we all get that, work better in productive, high-stress environments as teams. So that's kind of the long answer, or maybe the short answer. There's a longer answer, which involves what skill sets are we looking for and all that sort of stuff, which is kind of a blended skill set. We're not necessarily seeking out somebody who specifically knows how to deal with customs in Namibia.
Maybe I'll ask one last question.
Sure.
So through my interactions with ShelterBox, I've learned that there is an R&D center or organization that is being formed in the UK. So what brought this about, and what are some of the things that the center is trying to achieve in the short term?
Yeah, you're talking about our own staff involvement in the R&D piece of it? Yeah, so there's an association, kind of a sector association, and I made reference to that group when we were talking about the criteria for water, that has taken some of our internal people and who deal a lot with procurement, and really, it's probably a lowercase r, capital D, on the R&D concept. They're looking at different solutions, different materials, looking at processes and problems to be solved, and propositioning essentially the operations side of our organization to field test, to test and measure and see if some of these things could be better at the end of the day for our beneficiaries. It's in its nascent stages. I wouldn't say that it's something that's highly developed. From a capacity standpoint, we're in very much a capacity building mode right now internally, and it's something that we've aspired to do, just like monitoring and evaluation, and those things are starting to take hold and to take place. And that's why it's actually good timing for this conversation, because ShelterBox is small enough to be nimble and to be able to take on some research type projects using its staff, but it's big enough to actually get something done in the field, and it's quick enough to do that. So I think it's kind of at a sweet spot right now in capacity, being able to participate in that R&D aspect of things, and also take it to the field.
Well, thank you, Bill. I know you had to travel and out of your busy schedule to make it your way to here in Philadelphia. Thank you very much for the informative and inspirational talk.
It's a pleasure. Thank you, everybody.
So we have one last bit left, so we're going to close the symposium with a short talk, closing comments by Stebe.
You are a tough act to follow. I got a note, we're done, we're starting questions. And I've been standing back there and I'm thinking, I have all the time in the world. I was trying to think to give closing comments about what is the most important thing. And I started the morning in one of the ACT discussions, listening to students present their work and crosstalk between the students in the room and the researchers in Grenoble, and the input from, I want to say Denis, but it's Denis?
No, it's Denis.
Denis. The input from Denis, from Solvay, and I thought, That's the most important thing, that crosstalk and that development of fundamental ideas. And then I was heading out and I ran into Papillon. And we were talking about the beautiful interactions that are being seeded between the many faculty participating here in the United States and in Grenoble, and how to grow them. And I thought that's the most important thing. And then I got to come back and hear the discussions at the end of this inspiring talk. And you touched on so many things that are actually the most important thing. So one of the most important things is actually the most important thing. We are here as a community of scholars to make impact and do good on Earth. And that's the theme of REACT. And you were saying we have to be prepared to react. And I thought, oh, that's our name. We have to know what our core values are. What are we doing? And make our impact there. And then Karen posed the question about, well, why ShelterBox? Why a tent? We need communication and food and resources. Why that resource? And I thought, engineering. And so this is my real pleasure to call to end this symposium, where you're all doing the most important thing. You are building self-aware individuals among our undergraduates, master's students, doctoral students, and postdocs, and faculty, and our friends in industry, and our friends out in the NGOs. Self-aware individuals who want to make an impact through doing beautiful fundamental work, translating it into application to do good on Earth. And is there any better way to close a symposium and to wish you all an inspired Happy New Year?